Hey guys, welcome to another episode on MSK Coding. In this episode, I'll be showing you my solution to a Mathwalk. If you've watched the previous episode on Mathwalks, you already know what they are. But if you haven't and don't know what Mathwalks are, they are chalk problems, like this. See, it's written with chalk. And you can find them at bit.ly/mathwalks2020 or bit.ly.com/mathwalks2020. On Twitter, it's #mathwalk is the hashtag, and there's a Google Sites page, which the bit.ly link redirects you to. So that's how you can find the Mathwalks, and the Mathwalk that I chose is down here. Who am I? So, who am I questions are usually asking for a number. And as you see, the number has to be a 2-digit number, not prime. All of the digits have to be different. It cannot be a multiple of 2, 3, or 5, and at most, one digit is a multiple of 2, 3, or 5. So, let's tackle this from the starting clue. 2-digit number, which means that I can make my search shorter by going from 10 to 99. Those are all the 2-digit numbers. Then it cannot be prime, I will get to that later, but different digits is the second thing that I'm going to tackle. So, I tackled it by taking out all multiples of 11, because they are the only numbers that digits are the same. 11, 22, 33, 44, so on, so on. Then, I tackled it, not a multiple of 2, 3, or 5. I just said, this is basically, if it is a multiple of 2, this exclamation point equals negates that. So if it is not a multiple of 2, and it's not a multiple of 3, and it's not a multiple of 5, then put it in as one of the things that passed the test. Then, not prime. This clue was the hardest out of all 4 or 5. But it still wasn't that hard, because prime tests are pretty easy for small numbers. For larger numbers, they take up more amounts of memory, so it lags a bit. But for a low amount of numbers, like from 10 to 99, this is a good approach to take. So, first, for x in range, len of L. What this does is it basically makes it so for every item in the list L, it'll run this for loop. For y in range 2 to floor of square root of L of x. Well, what does that mean, first of all? So, floor of square root of L of x. Let's take it from the inside and go out. That's always the best way to deal with parentheses problems. So, the inside L of x, that changes because x changes. So, the number starts, like, that number starts as, let's say, 2. It's not 2, of course, but let's just say it's 2. Then it moves on to 3, and then it moves on to 4. Again, those are not the actual numbers that it gets filled in with, but that is it, basically. And then you have to take the square root of the number. So, you know what taking the square root is already, probably. And then floor. That is the one that most people might not know. Well, floor basically just rounds it. It's rounding up. Or down. It's rounding down, actually. It's because of floor, let's take a house, right? The floor is at the bottom and the ceiling is at the top. So ceil would be the one to round it up, and floor would be the one to round it down. So that's what this is doing. Then it takes, if L of x is divisible by y, then you append z L of x. so it's a second test. Then you would think, oh, okay, then we'll go to at most 1 digit is a multiple of 2, 3, and 5. No, we're not going to do that. Why? Because let's run the program and see why. It only spits out one number, which means if you go through all 4 tests here, you do not need the 5th test. I'm thinking that if you didn't go all of these, you will need this. But in this situation, where I coded through all 4 before the last one, we don't need the 5th one. So that's how that is. And I'll see you later. But one more thing. We are really close to 100 subscribers. We only have about 20 subscribers left to go. So, if you're not subscribed and you like this video, please subscribe. It will help a lot.